Good afternoon, ladies and gentlemen. Once again, Miss Freeland coming at you with our science lesson for today. Today's science lesson continues our conversation about energy with the discussion about collisions. Collisions occur many times throughout the day. Even with simple walking up and down the hallway, you are colliding with the floor as you walk. You are going to need today your green spiral notebook. You will need scissors, glue, and a pencil. From your green science folder, you'll need 2 worksheets, Chapter 5 Collisions, the interactive notebook activity sheet, and Chapter 5 Collisions, the mini assessment. You can take that Chapter 5 Collisions and cut along the solid lines to cut out the illustration in the center of the page. Find an empty spot in your science notebook and glue that kind of towards the middle. If you want to wait to glue to find out where I put it, pause the video, get yourself assembled, and we'll glue together. Thank you. Okay, ladies and gentlemen, welcome back. I found the next empty page in my notebook and I wrote Lesson 5 Collisions, but I still have not glued down my piece of paper. So remember, we're only going to put glue just above that dotted line behind the word collisions and fold on the dotted line once it's glued down. We do have some writing to put under that fold as we kind of described what is happening in the picture. I'm going to use kind of the hole that's punched into my spiral as my guide and just go a little bit above the hole, giving me plenty of room to write above and some room to write under and below. That was kind of an ugly glue. You know, I like to follow those lines. I'm a little particular. All right, so capping my glue stick and setting that off to the side, putting it away. I'm ready to kind of begin our notes. So collisions, as I said earlier, collisions happen every day. Collisions are basically an interaction between 2 objects that physically come in contact with each other. Like I gave the example of our tennis shoes or our shoes hitting the floor each day as we walk. That's a very basic, very simple form of a collision. Sometimes your desk, when you open and close your desk and you drop it, that's another example of a collision. Any object or any 2 objects coming in physical contact with each other is the basic definition of a collision. So I'm going to start by writing that here at the top of our notebook. Again, if I am moving too quickly for you, remember, let me get all the writing finished, and then you can stop the video or pause the video and copy it. So simply, a collision is an interaction between 2 objects that physically come in contact with each other. That there is our basic definition. So a collision is that interaction between 2 objects that physically come into contact with each other. So a couple details just about collisions. One of those details I've always appreciated kind of as a basic law of physics, a basic law of science, is that each object is going to exert a force, some type of push or pull that's equal but also opposite to the other object's force, the other object's push or pull. So we say that each object exerts a force, exert being just a fancy word for gives off, exerts a force that is going to be equal and opposite to each other. Another little note for these collisions is that the force exerted by each object actually depends on the amount of energy that's held within the object or that the object has. So the push or the pull, the force exerted by the object depends on the amount of energy each object has. If the object has a lot of energy, it's going to exert a lot of force. If the object does not have as much energy, it will not exert a great force. It'll be very small and kind of wimpy. All right. The last note about collisions is that most of our collisions involve at least one moving object. So one of the objects in a very standard, a very basic collision has to be moving. It has to have that kinetic energy to be moving or in motion, and it's going to come in contact with either another object with some kinetic energy in motion or a stationary object, an object just sitting there with some potential energy to fight back. So most collisions, not all, but most, involve at least one moving object. That collides with a stationary object, something that's standing still, or B, a second moving object. Okay. So most of those collisions, just taking a second, involve at least one moving object that's going to either collide with a stationary object, like the example I gave with us walking. We would be the moving object. Our feet are moving. Our feet are in motion. And our feet are colliding with a stationary object, as in the floor. If we talked about two moving objects, we might talk about a lot of our sports. Standing at home plate, ready to swing a bat, we would have the swing of the bat as one moving object colliding with the ball coming towards us as the second moving object. We would consider that strike or that crack of the bat, ball hitting bat, as a collision. Okay, we have a lot of sports analogies, sports examples that we can talk about with collisions. One of the collision examples is the one illustrated here. So I took a second, and you're welcome to pause the video and kind of jot down what I have here, but I took a minute just to kind of describe what was being shown. So basically, this is an example of a very simple and very basic energy system. An energy system includes all of the objects seen, so all of the objects we see in the system, such as the ball and multiple pins. It also includes the flat surfaces, so the lane or the alley that we have the ball rolling on, and the pins that the alley that the pins are sitting on. And we even include the air as part of our energy system. The air kind of includes or comes into play when we're creating sound energy and other forms that are happening. What I'd like to do is kind of label the forms of energy that are occurring here as the ball comes in contact with the pins, and then we'll lift up under and we'll kind of give a much better description of the collision that's actually being shown here in the picture. So we have a bowling ball. Okay, if we're standing in the lane and we're getting ready to bowl, we need to give this ball some form of energy from ourselves, the human being. What form of energy are we going to need to add to the ball to get it moving with kinetic energy down the lane? Yep, go ahead and say it out loud. You're sitting at home by yourself. Nobody should be listening. If you said mechanical energy, you are absolutely correct. We need to give this ball some motion. We got to get it rolling. We give this ball some mechanical energy. Now, that mechanical energy is transferred down the lane, and it's given through a collision to these pins. Now, several different forms of energy are created with these pins, okay? We get some additional mechanical energy, and I'm just going to say ME down here, because the ball is going to continue moving. Once it hits and collides with the pins, the ball just doesn't immediately stop. But in that collision, it rolls off to the side, the left or the right, or continues going straight ahead as it continues with the pins. So the ball maintains some of that mechanical energy. Some of the mechanical energy is also transferred into the pins themselves. So the pins are going to get some of that ball's mechanical energy going into the pins. Some of the mechanical energy originally generated is going to create sound energy. A bowling alley, if you have ever been in one, is not a quiet place. It is very loud. It is very noisy, not just from the people talking as they're bowling, but actually from the ball hitting the pins and creating that sound energy when that collision occurs. Another thing that's actually created during this collision is thermal energy, the form of heat. The thermal energy is created through that friction that needs to be overcome by moving those pins off the lane. So we get a very small amount of thermal energy created as that ball overcomes friction and actually overcomes the friction holding the pins in place, moving those pins away with that mechanical energy. So we have a lot going on in this illustration, and there's a lot happening with collisions each time they're occurring in the world around us. So using this picture, we're going to kind of flip back and forth and refer back to it. So if you need to take a minute, pause the video and get kind of caught up with me, go right ahead and do that. So I'm going to continue. I'm folding up on that dotted line, giving myself a whole bunch of space to kind of continue writing some of our notes. We have a couple other quick conversations to have, what actually occurs during a collision. Kind of already talked about that when we labeled the picture, but I'd like us to kind of write it out so that we do have a deeper understanding of collisions and how they occur. So one of the big ideas is that during a collision, the motion of each object changes. What this means is, this means that the speed of each object changes, and the direction of motion changes. Okay, so what does this mean for the bowling ball and the pins that we have in the picture? So if we stop a minute and we think, I have to add mechanical energy to the ball. The faster I get the ball moving, the more force I add, the greater the speed the ball has as it moves down the lane. Now, waiting for it are pins. Those pins are stationary. Those pins have no speed whatsoever. When I roll that ball, part of the speed of the rolling ball is going to be transferred into the pins. That speed of the ball is going to slow down, but the pin speed is going to speed up. They're going to go from stationary, 0 speed, to having quite a great deal of speed if I've done my bowling with some skill and some accuracy. We also have a change of direction or a change of motion happening, the direction of motion. The ball is going to continue down the lane, but once it comes in contact with the pins, once it collides, the ball is going to change direction. And it's going to go right, left, or somewhere scattywampus down the middle. The pins are also going to have a change in the motion, the direction of motion. They were standing still, and if you've ever observed bowling pins, they're going to scatter and go all over the place, again, if I'm a pretty good bowler. Another thing that's going to occur during a collision is that energy is going to be conserved. So during a collision, energy is conserved. Okay? What this means is that the total amount of energy that started with the initial bowling ball is going to remain the same as all the different forms of energy coming out of the bowling ball. The energy will not be created, nor will it be destroyed. It'll simply be transferred or transformed from different objects to another object. So during a collision, energy is conserved. This means that the total energy of the system, like we were talking about the bowling system that's in our picture, the total energy of the system remains the same. No energy is created or destroyed. Okay? Lastly, most collisions begin with the mechanical energy of a moving object. That energy, let's say that mechanical energy, and I'll abbreviate it, is either ... A, transferred. We've talked about transfer of energy. It's transferred to another object. Or B, it is transformed into another form of energy. Got my R. Okay. Like we have in the picture, that mechanical energy originally given off by the bowling ball stays mechanical energy as the ball continues to move or the pins now start to move. That's the transfer of that mechanical energy. Or the mechanical energy from the ball is transformed, whether it be sound energy or that thermal energy that's created to overcome the friction of the pins standing still. So take a minute, pause the video if you need to, make sure your notes look like mine. Make sure your illustration is complete. If you wanted to add some color to it, if you've got a few minutes, go right ahead. But this concludes our conversation on Lesson 5, Collisions, for our science unit on energy. At the end of the video, remember to take a second and review it, talk about it, discuss it, reread it, before you continue moving on into our assessment today. The mini assessment has been typed into a Google form. If you don't want to use the Google form, you're welcome to complete this and turn it in to me when we return face-to-face next week. But I would strongly suggest just quickly answering the questions in the Google form and submitting it to me by the end of the day. First 3 questions are always multiple choice. Should be pretty simple if you've paid attention and followed along with the video. And question 4 will be just a quick short answer. Typing your answer in complete sentences using good capitalization, punctuation, and spelling. I do know that there is a question on the back, but you do not need to answer that question 1 on the back. It is not assigned, just the 4 questions on the front. If you have any questions, comments, or concerns, please reach out and let me know. I hope you enjoyed today's science lesson, and I look forward to seeing you sometime soon. Thank you all, and enjoy science. Bye.